Hello, my name is Praveen and I welcome you all to my YouTube channel Java Fun. Today we're going to talk about Fibonacci sequence. This is the most frequently asked interview question. A lot of MNCs do prefer this question not only at the beginner's level but at the intermediate and the experience level as well. One of the core reason for this thing is this particular problem not only tests candidates programming knowledge but also tests his algorithmic knowledge as well. So today we're going to find out how to implement this thing in Java. Mainly there are two different ways by which you can implement Fibonacci sequence. Firstly by using loops and second approach is by using recursion. We're going to see two different variations of these two main methods as well. We're also going to find it out how to calculate time and the space complexity of both of these algorithms. If you're coming to my channel for the first time, please do like, share and subscribe. We do make videos about all the interesting Java concepts. I'm creating a whole series of Java programming questions, so stay tuned. Please watch the video till the very end. I'm sure after finishing this video, you will get well versed with Fibonacci sequence. So to start with, what exactly is the Fibonacci series? Fibonacci series is a series of numbers which is first invented by an Italian mathematician called Fibonacci. There are multiple usage of Fibonacci series in the real world. Uh, there are different scientific usage or the implementations of the Fibonacci series. For us programmers, the most common usage of the Fibonacci series is in agile methodology, wherein you use the Fibonacci series to calculate or to define the complexity of the requirement. According to Wikipedia, Fibonacci numbers are commonly denoted as f of n, and this is nothing but wherein each number in the sequence is a sum of preceding two numbers, which starts from 0 and 1. So as the definition suggests, the first two numbers in the sequence will have a constant value. So f of 0, which is the first number in the series, will have a Fibonacci value of 0, followed by f of 1 will have a value of 1. The next number in the series will be f of 2, which will be a sum of f of 0 and f of 1, which is 0 plus 1 is again 1. The fourth number in the series, which is f of 3, that will be a sum of f of 1 and f of 2, which is 1 plus 1 is 2. F of 4, sum of 1 plus 2, which is 3. And f of 5 is a sum of 2 plus 3, which is 5 again. And the same thing will be followed in the sequence. Now let's see how we can implement the Fibonacci series in Java. So before implementing any of the program, we need to understand what is the algorithm or how we can devise its algorithm. So as I told you, there will be mainly two different ways by which we can implement the program. So let's see if we can implement by using a loop. Suppose if I want to calculate the Fibonacci series till say n is my limit for the series. What we're going to do is we need to loop from 0 to n, and as we see in the PowerPoint presentation, the first two numbers in the sequence are constant. So if and I'm looping basically, so let's see the index of the loop is suppose I. If I is equal to suppose 0, then its value will be 0. If I equals 1, then return, so basically its value will be 1. I say val 1. Similarly here val will be 0. Now for all other numbers, basically you need to do a sum of And suppose if I'm storing this into variables, I store this in suppose A and I store this in B. So basically the third value in the sequence, which is suppose C, it's a combination of A plus B, and it will be continued till your loop terminates. Similarly, in case of recursion, again, if I equals 0 or I equals 1, then return I. Basically, return the same value of I, which is maybe a 0 or maybe 1. Else what we're going to do is return, as it is a recursion, it will be uh, calling the same function again, but with different parameters, which will be a sum of I minus 1 and I minus 2, which is a Fibonacci of I minus 1 and I minus 2. So this is our algorithm, and we're going to find it out how we can implement it in Java. So let me go to my IntelliJ IDEA. This is a simple Java workspace. Now let's find it out how we can implement it. So let me say in this thing, I'll basically rename this particular class. I say Fibonacci using loop. Okay. Now most of the times interviewer basically gives you a constant number in the series, or he may say that you basically take an input from the user so that the program becomes more dynamic. So let's see how we can take an input from the user. Then input will be how big or how long your Fibonacci sequence should be, and we're going to create the Fibonacci series which is that long. So let's say sysout, say please enter the limit for the series. Now if you coded in Java, you know there is a class called scanner, which is basically used to read the user input. So I'll get a scanner object. So I'm getting a scanner object, and for the scanner object you need to pass a standard input string. Okay, and that input from the user, I'm gonna save it into an integer. So I'll say limit scanner dot next int. So this will be our limit, and as we discussed last time, what you're gonna do is basically we're gonna loop in the series. So I say int I starts from 0 till limit plus plus, and we are basically not doing anything but just following the steps that we decided into our algorithm. So I say if I is equal to 0 or I equals 1, basically return I, or basically what I'm going to do now is I'm not going to return anything, but we basically take two different, I basically define an array basically, and I'll storing the elements into an array, and which while doing a sum basically will retrieve the element from the array using an index and then do a sum. And I'll show you another variation of this one as well, and then we'll basically determine which is the better approach to be used, whether by using an array or by using variables. So let's say I define an integer array. I say numbers equal to new integer array, and its bounds will be till the limit. Now what I do is basically if it is 0 or 1, then I say numbers of I will be equal to I, else basically numbers of I will be equal to numbers of I minus 1 plus numbers of I minus 2. Pretty simple till now. So let's see if this program is working. So basically let's print out the series after this one so that we know what are the numbers that we have stored into our array. So I can use a similar loop, or I can use the streams API provided by Java. So let's do it using the streams API. I'll say numbers. For each, basically I'm gonna print it. I'll print this number and put a little space after it. So let's not do new line. Let's print everything in the simple same line. Let's see. So this is our program, and we'll see now if it is working or not. I'm running this particular main method. Give it a couple of seconds for build, and then we'll see what is the output that we get. Okay, it's building. Okay, so please enter the limit for the series. I say 7. So this is my series. As you can see, the first two numbers are 0 and 1. Then the third number will be a combination of the sum of 0 plus 1, which is 1, 2, 3, 5, 8. So series is basically calculated properly. So this is the first thing that we did with using an array, where we are storing the numbers into an array. Now, as I told you, I'm going to show you one more approach, basically by using the variables. So let's see how we can use the variables to calculate the same series. So what I'm going to do is I'm going to create one more class. I say Fibonacci using variables. Let's say I'll copy paste the same thing because most of these code we are going to reuse. Okay, I'm going to take scanner object as well. Okay, now we basically don't need the integer array. What we're going to do is we're going to take two numbers. I say int a and int b, which are nothing but denoting your first two numbers in the sequence. Okay, and as you guessed by now, the third number will be a combination of a and b. What we're going to do now is, so because we defined these two numbers already, let's start our sequence with 2. What we're going to do now is we basically swap the value in each iteration of the loop. We're going to swap the values of a and b, so that when the next iteration comes, we're going to have a correct value in a and b for our summation. So what I'm going to do is basically I say a is equal to b and b is equal to c. So what I did is basically whatever is my most recent value in the series, which is b, I swap that value with a, so that becomes my second most recent value when the next iteration comes. And the last value of the summation, which is c, I swap with b, so that my two values or two variables a and b accurately depicting the preceding two values within the series. So let's print it out and then see if the series is correctly getting printed till now or not. Okay, it's building. Let's give a couple of seconds for it to build, and then we'll perform the same thing that we did with the first program. Again, the series is getting printed. I think there is an issue here because we haven't printed the first two values within the sequence. So let me print them as well. Okay, so and we don't need a new line. So let's print it all the series into the same line. Okay, now let's see. Should work. Put 7 again. The series is getting calculated absolutely fine. Now I show you two different approaches for loops. Now the question will naturally come in your mind is, which is the better approach and which one should I use basically? Now the answer for this thing is, there are several factors for its determination, depending on which algorithm you want to choose. One of those factors will be, do you know basically beforehand how big your series is going to be? If we are talking about a pretty small series, then I would go with the approach 1, because approach 1 gives me certain advantages in the sense that I always have the different values in the series stored within the particular arrays, so that if I want to test this particular function, right now everything we are written into the main method, but if we move this particular logic into the particular method, I want to write the JUnits for it, I want to write the tests for it, I can basically return the exact array back to the calling function, and the caller basically do a certain assertions onto the values and the length of an array to determine if my series has been get calculated properly or not. So that's first thing. In terms of time complexity, both those approaches are using the loops, and they're going to iterate for exactly at the same number of times. So from a time complexity perspective, uh, there is not much difference within these two approaches. But if I talk about the space complexity, as in how much is the space basically has been used by both of these approaches, definitely the second approach is a much better approach. So before going to a recursion phase, let's going to talk about what will be a time complexity for the loop. So what we're basically doing is, suppose if I'm calculating the fib of 5, right? So I'm going to loop for exactly 5 times. So my time complexity is basically O of 5. I'm looping for 5 times, or simply putting O of n in both of these approaches. So I'm not really uh, getting or having much difference in terms of execution time in both of these approaches. However, if I say I'm gonna use an array approach, then what is basically happening is, I'm going to create an array, and that array size is going to increase exponentially to whatever is the limit of your series is. Suppose if my limit is 5, then array size will be int of 5. If that is 5,000, your array size becomes that bigger. So basically, the space complexity, the memory utilization for your algorithm is going to increase exponentially as the limiting factor for your series is going to get increased. So depending upon what is your problem statement or whatever is the problem domain, you need to choose the specific algorithm that you want to execute. Now, before going to recursion, let's do one more thing. Let's print out the time taken in both of these approaches. So what I'm going to do is I'm going to take a long start variable for the start time of my program, and after it is finished, or here it is finished, so let's do print here itself. This out, time taken equals system dot current time is minus time. So this is going to print the time taken in milliseconds. So let's see. For the smaller series, right, that we took numbers like 7, you'll not see much of a difference in not only for these approaches. For the next approach that we're going to use is your loops, sorry, in recursion. There will not be much of a difference, but as the limiting factor which user is going to provide starts getting increased, you're going to see a substantial difference between these two algorithms. Let's do this thing. Long start system dot current time in millis. Okay, so let's run both of these loops for a fairly big number. I would say 56. Okay, time taken is around 3100 milliseconds, which is roughly 3 seconds in a array approach. Now let me run for the equal number of limiting factors. Okay, where is it? Time taken is 5 milliseconds. So you can see the difference in both the approaches. So this would have given you an idea in case you want to decide based on which approach you want to use. This is going to give you an idea. So time taken is even lesser in this situation because the compiler might have done certain optimizations. Okay, let's try one more time. Should be comparable between 1 milliseconds again. Okay, so there is a quite a lot difference between these two approaches, mainly because the memory consumption that we're doing. We're basically putting something into the memory, taking it back, putting it back again, and all those things that we are doing. Okay, so now let's go to a recursion approach and then find it out how we can implement this particular program using recursion. Fibonacci using recursion. Okay, again, let me copy the things that we have created last time, because mostly user input and everything remains same again. Okay, I go to a recursion one. Fairly simple to implement again. However, as I told you last time, it tests your algorithmic knowledge. Programming wise, it's not very complex to implement. Okay, so till now I'll keep it. I remove the other part. Now let's see. I'm gonna run a loop int I equals 0, I less than limit I plus plus. And what I'm gonna do is I'm gonna print the value of Fibonacci series, and I need to create a function called fib, which will return an integer for me. So I'm going to create a private function called fib, expecting an integer, returning an integer. Again, as discussed last time, if I equals 0 or I equals 1, then return the same value, else return fib of, and this is a recursion call that we're doing. And the question for you, you're going to tell me whether this is a tail recursion or a non-tail recursion. And if you don't know what is tail recursion, please comment me and I'm going to create another video explaining you what are the different types of recursions that we are having. If you are liking till now what am I explaining, please go ahead and like or share or subscribe my channel. You're going to see a lot more similar kind of videos coming into my channel. Sure, now let's see if this works. Run. Here we're not using any array or anything. We're just calling the function in a recursive manner and printing its value. Again, it's printing fine, no problem with that. Now we're going to find it out. How much is the time it is taking? And the time complexity for this thing will be a tricky thing to calculate. This is working fine. Now let's do one thing. Let's print out the total time taken. Okay, total time taken. Again, system.current time in millis minus start. And need to put it in a braces. Sure. Okay, let's run it for a fairly large limit. As the last two programs, let's run it for 56. Still running. So you can see the time taken is exponentially larger in this thing, in this particular case. And it's a good possibility that we may not get a result as well. If the stack gets overflowed, it may throw an exception, or stack overflow exception as well. So let's see if it works or not. And this would have given you a fair bit of idea that using a recursion is not really a good approach for a good algorithm for a Fibonacci series. Still running, and it's gonna get stuck, or it's gonna throw an exception. Let's give a couple of seconds. If it doesn't return, we're gonna kill this program. I don't want this to get crashed. But this should have given you an idea that how expensive this innocent looking algorithm is. You run it for a fairly big number and it started crashing. See, must have elapsed a minute or two till now. Still no answer returned. Okay, let's kill it. Let's run it for some small limit. Let's see, I say 10. Time taken is 4,400 milliseconds, which is roughly 4 seconds, which is fairly large compared to all the other approaches that we have seen. Even with the array approach, we have got a result in less than that time. So, recursion is really not a good approach to be used But is there any way by which we can basically speed up the execution of this particular recursive algorithm? And the answer is yes. You might have seen this technique in some of the other recursive algorithms as well. What we're going to do is we're going to use a technique called as memoization. And what memoization is, the memoization is a word basically created from a memory. So what we're going to do is we basically keep certain values within the sequence in the memory, or we're going to cache those values so that we don't need to run the recursion and don't need to fill up my stack using those values, and I'm going to get the readily available values, and which hopefully will speed up the execution of this particular program. So let's see how we can use the memoization technique in recursion. Spelling memoization. Okay, so let's see. Again, it will be a copy paste of your earlier code. So let's see. And as I said, we need to store the intermediate values within the sequence. So again, I'm going to use our friend, which is a integer array. Let's use an integer array. I say numbers, a new integer array. Bounds will be till the limit. Okay. Now what we gonna do in this particular thing is we're gonna store the value into an array. So if it is 0 or 1, just return I. There is no change needed here. What we're going to do here is, before calling the recursion, we're going to check if, and I'm going to need to pass this array now. I say integer array numbers. I'm going to pass the numbers here so that I can check in my recursion function if the value for this particular index or the number in the sequence is already present in the array. Okay, so let me see. Okay, what I'm saying basically here is if the value of I is already present, there is something wrong. Okay, if what I'm saying is if the value of I is already present there into an array, basically return the same number. You don't need to calculate it again. So this is basically saving you from the recursion loops in these scenarios. Else, if it is not there, then what you need to do is basically you need to calculate the value and then need to store it into an array. Okay, so we calculated it and now we stored it, and then I'm gonna return the same value back again so that it gets printed into my program. Okay, fairly simple till now, and this is complaining because I need to pass the number array to it. Okay, let's go and see if this works now. Let's start with a small number first, and then we're going to run for a fairly large number like 56 that we did last time. So this is working fine, although the time taken is still fairly on a larger side. As we told, this is not really a performant algorithm that we are doing. Let me run it for again a large number. I say 56. Okay, this time it is finished properly. Time taken is 4 seconds. So this is how, this one of the technique called memoization. You can basically improve the timings of your recursive algorithms, or you can make your recursive algorithms more performant. Okay, so we come back to the algorithms again. So we implemented it. We know how to implement it in Java. Now, always remember, whenever you are in an interview situation, when you answer one question, interviewer will ask you a counter question on it. Now, suppose he asks you to implement Fibonacci using recursion and you're able to do it, there will be a further follow-up questions on it. Namely, I would suggest it will be mainly around what will be a time complexity of a recursion, what will be a space complexity of your recursive algorithm, such kind of questions. So now let us go back to time and the space complexity again. Now we implemented the Fibonacci series using loop with array, and we know that if you are using variables, your space complexity becomes remaining O of 1. Using recursion, that is something that you need to find it out. So using recursion also, we implemented the simple recursion with the memoization. And the third thing I need to show to you is using a Java stream. So first, what we're going to do is I'm going to basically show you what is the time and space complexity in case of recursion, and then we're going to dig into the implementing the Fibonacci using the Java 8. And this is again a variation of the question that people started asking recently is, yes, you may know using a loop, you may know using a recursion, but do you know how to implement it using a new Java Streams API? So we're going to find it out how we can do it. So let me go back and show you what will be a time and space complexity of the recursive function. So to basically understand the recursion that we did just now, we need to find out how many times your recursive loops is going to get called. Basically, if I take an example of suppose a recursion of 5, then basically it will call for the first time, which is n minus 1, which is 4, n minus 2, which is 3. Then 4 will call recursively for 4 minus 1, which is 3, 4 minus 2, which is 2, for 3, 3 minus 1, which is 2, 3 minus 2, which is 1. Now, as we saw in our program, once it reaches the value 0 or 1, your basically recursion loop terminates there. So for this particular branch, it's terminated. So let's continue with the other branch. If I say f of 3 minus 1 is 2, 3 minus 2 is 1, this loop terminated. Now 2 minus 1 is 1 and 2 minus 2 is 0. F minus 1 is 1, f minus 2 is 0. This again, f minus 1 is 1, f minus 2 is 0. Now, if we can go back to the recursion function, what we are seeing here is, so this particular thing is basically a constant time going to take for any length of a Fibonacci sequence. So whatever I'm doing, basically this is a constant time. It will be there for each and every step that I'm going to execute. So let's say that constant time is suppose c, and what is happening is for every step we're going to execute f of I minus 2 and f of I minus 1. So for executing a single step, suppose we think that for executing just suppose I minus 2, I say it needs me a t amount of time. So basically what will happen is for this particular step, I would need 2t plus c, which is your constant time, and time it taken is basically 2t. For the next step will be basically 1, 2, 3, 4, which is will be 4t, and C, which is constant time again. And the next one would be your, basically, if I calculate the entire thing, basically because your left hand side branches are basically longer than your right hand side branches, because right hand side is going to finish fairly quickly. Left hand side of branches, basically these branch is going to execute for fairly longer than your right hand side of branches. So whenever you are calculating time complexity, you need to find the upper bound always. So you do not need to find the shortest time it is taking, but the longest time it's going to take, basically. So for this thing, if you say, if I'm running it for f of 5, how many times I need to execute this thing particularly? So if I say 1, so if I just calculate how many times I could call this fib function, I say 1, 2, 3, then again this 4 is 7, 8, 9, 10, 11, 12, 13, 14, 15 times I basically called. So it is basically 15t plus c. So if you see what is happening here is 2 is basically 2 raised to power 0 plus c. 4t is basically 2 raised to power 2 plus c. So at each level, so I'm, suppose this is level 1, this is level 2, this is level 3, and this is level 4. So at each level, what is happening is basically you are doing 2 raised to power n minus 1. If you see how many times we are calling it, basically, so suppose this is 15, I would say, which is basically 2 raised to power 4 minus 1, which is basically 15. 2 raised to power 4 is 16, and this is 16 minus 1. So if you want to basically approximate the time complexity for the Fibonacci series in recursion, basically it will be somewhere around 2 raised to power n. This will be your time complexity for the Fibonacci sequence. And let's see, for the loop we have seen, space complexity we have seen as well. With array it will be O of n, it will gonna be directly proportional to whatever is the limit of your loop. Without an array it is O of 1 that we saw when using variables. And say in case of recursion, that is something that we saw just now, how your tree is going to explode into basically into the stack. So that is how it's going to basically gets called. Now, as we told, its complexity is basically 2 raised to power n. Space complexity is again O of n because you're again storing the values there. So this is basically using recursion and the memoization. The last part that we talked about is how to calculate it using the Java 8 streams. So I assume that you guys having a little bit of knowledge of prior knowledge of Java 8. So we're going to see how we can implement it using Java streams. Fibonacci, sorry for that, using streams. Okay, let's again get some of the common code that we need. Main method till the limit. Now we go here, paste that code. Okay, now what I need to do is I just need to run my loop, run or iterate in streams over these values and calculate their sum. So what I'm basically doing is I'm using the stream.iterate function. My first value for this function basically is a seed object. So seed object is nothing but your starting object on which you're starting your computation within the series. So for me, my seed object will be array, and I'm giving an integer array for it. And as you could have guessed by now, is values for my integer array, initial values will be 0 and 1, which is basically my first value and my second value. Now the second argument for this thing is basically a lambda, which is going to calculate the calculate the sum of preceding two values for it. So need to define the integer array again, and how to calculate their values. So let's say f of 1, which will be your first value, and then I say f of 0 and plus f of 1. So that's how we basically going to calculate. So at each loop we are going to create a new integer array, and we're going to put two different elements into it. Okay, and now I need to limit this particular sequence with the value or with the limit that we want, which is we received from the user. Now what is happening is at each streams loop we are receiving a new integer array basically, but we don't need an integer array basically having two different values in it. We don't need two different values. We just need a first value from the array. So if you have noticed by now, is this is what is happening. So this is my first, when my loop gets executed for the first time, then this is for the second time, then this is what is happening for the third time. So this is basically 2, 1. So this is my first value, and this is basically a sum of these values basically, and the other value which is remaining there. So what we basically need in this scenario is we need a sum of, or we need the second value that we are getting into the from the array. So let's do one thing. I'm going to map it. So what I'm going to do is I'm going to receive the first value of my array, and I'll just print it out. So I say for unity, just print just to this out. Again, we don't need a println for this one. What I'm going to do is just print the value, put some space after that. So let's see if this works. A little bit complicated compared to the other loops or recursion that we saw, but it's pretty concise as well. So let's see. So I'm going to get my recursion. Sorry, not the recursion. I'm going to get my output using the streams as well. So this is basically it for this Fibonacci series. Again, if you have enjoyed my video, if you think that you get something new regarding the Fibonacci sequence, please do comments into the video. Tell me what the things that you like, what are the things you don't like, what are the things that any problems that you want me to be explaining to you. I'm pretty much happy to create a new video for it. And please do share this particular video with other persons that may be benefited from this one. Please subscribe to my channel. Please press the notification icon. All these programs are basically checked in into the GitHub. I'm going to put a GitHub link into the description of this particular video. So uh, if you want to go and find out the code snippets for it, it is already available into the GitHub. So thank you very much. Thanks for tuning in. Have a fun. You're learning Java.